design processes by Group 6.
So let's get started with the definition and the significance of design processes. Typically, the definition would be a methodology that provides a solution-based approach to problem solving or solving problems. It's nonlinear and an iterative process that can have anywhere between 3 to 7 phases. Typically, this depends on exactly who you're speaking to because they can be additional. However, for future reference, we only narrowed it down to 5. And the significance of this would be that it's very easy to show to a client what progress you make exactly in the project that you're in. This is designed with logic in mind, so it makes it very simple for people to understand. This is a good thing because you're able to properly portray where you are in a project and how you're going about it, and the client will be able to understand it. Continuing on with the overview, as we said before, there are about 5 main stages that we've decided to narrow it down to. The first of which is to empathize, which is to research your user's needs, where you can go on Google, internet, or even to other people and ask, what does this user need? Then you define, which is to state the needs and problems. So this is where you're starting to figure out solutions to the problem. And that leads into ideate, which is you're challenging your assumptions and creating ideas. And so then you get to the prototype where you are starting to create the solutions that you thought up. Then you test it to try out those solutions. And typically they could be done concurrently and completed by different members due to its nonlinearity and flexibility. You can even go back and redo certain steps because something may have gone wrong in the step or a future step. You might be asking yourself now, what's the relevance? Well, in engineering design, we're designing a solution to a problem, and that's leading up to what our project will be eventually. The design process is a step-by-step guide and plan as to how a solution will be brought up, such as a specific need for hardware being developed, program being coded, or even ordering needs such as transceivers or resistors or capacitors and the like. In practice, you might be able to give a progress report to a client or your contractor to show, hey, this is where I am, this is what I'm doing, I might need more time, less time, it should be ready by this date. So the design process allows an engineer to communicate exactly where they're at with the project or a solution to a problem in an orderly and concise fashion that the client or contractor should be able to understand with little to no difficulty due to the basis in logic and the conciseness of the design process. As such, it is extremely relevant and very important to remember.
Design processes are important in the product development. The 5 stages in the design process are used to design products that fit target consumers' needs, which is important when trying to prototype, test, and refine the product. Empathizing and understanding what the consumer needs is essential to build a product for that target audience. Documentation is also very important. Making sure that every process or every step of the process is documented makes sure that we can avoid repeating past mistakes and focus on improving and moving forward. This impact on society is that we get more improved solutions and sustainability. By using this process to test and refine a product, we are wasting less resources on the testing phase or on the development phase. And it also helps promote problem solving and thinking for long-term solutions and not just solutions that will work for right here, right now.
Hello, my name is Nathan and I'll be covering ethics in design processes. When we talk about engineering design, we often think about creativity, efficiency, and solving problems. But one of the most important parts of design is ethics. Engineers design things that impact people's safety, their health, the environment, and society as a whole. The National Society of Professional Engineers, for example, says that our first responsibility is to hold paramount the safety, health, and welfare of the public. When ethical concerns are ignored, the consequences can be serious, such as accidents, environmental harm, or the loss of public trust. That's why ethics matter, not just at the end of a project, but at every stage of the design process. If we look at the stages of engineering design, ethical issues appear at each step. Right from the beginning, when we are identifying the problem, we have to ask ourselves some questions. Are we solving a problem that truly benefits society, or could our solution unintentionally cause harm to certain groups or the environment? It's not enough to focus solely on efficiency or profitability. Ethical considerations require us to think about the wider impact of our work and who might be affected. Moving into the analysis and design stage, ethics become even more concrete. We need to think about safety first and foremost. Are the materials and methods we're choosing truly safe for the people who will use this product? Are we considering sustainability so that our solution doesn't create long-term environmental problems? We also have to consider fairness. Are we designing something that everyone can access, or are certain groups being excluded based on cost, ability, or location? When we reach the implementation stage, ethics guide our behavior in very practical ways. Honesty and transparency is critical here. Cutting corners in testing or misrepresenting results might seem like an easy shortcut, but it can have dangerous consequences down the line. Ethical engineering means committing to integrity, even when it's inconvenient or costly, because the potential consequences of ignoring ethics can be severe. Ethics are not something we can tack on at the end of a project. They are woven into each step of the engineering design process. Now we're going to look at some examples of when ethics were ignored. The Ford Pinto in the 1970s. The car had a serious design flaw. Its fuel tank was prone to rupturing and rear-end collisions. Internal company documents later revealed that Ford had conducted a cost-benefit analysis comparing the cost of fixing the flaws versus the cost of potential lawsuits from burn injuries and deaths. Shockingly, they concluded it was cheaper to pay for lawsuits than to redesign the car. This decision, driven by profit over safety, resulted in numerous fatalities and serious injuries. The Pinto case highlights how failing to prioritize ethics and human life in engineering decisions can have terrible consequences. The Flint water crisis in Michigan is a more recent example. In 2014, the city switched its water source to save money. The engineers and city officials ignored critical corrosion control measures. Lead got into the drinking water, exposing thousands of residents to toxic levels. In this case, ethical issues were combined with engineering oversight and public policy. Engineers failed to act on known safety risks, and officials downplayed or dismissed the concerns. The result was a long-term public health disaster, which shows how neglecting ethical responsibilities in engineering could impact entire communities. The Volkswagen emissions scandal shows how ethical lapses can extend beyond safety to trust and environmental impact. Volkswagen designed software in certain diesel vehicles to detect emissions tests and temporarily reduce emissions during testing, while in real-world driving cars emitted pollutants far above illegal limits. This deliberate deception caused environmental harm, violated laws, and eroded public trust. Technically, the cars worked as engineered, but ethically they were a failure. Ethical responsibility is just as important as technical skill, because the products we create can save lives or put them at risk.
Hello, my name is Bryan Gatto, and I'm here to talk about potential issues encountered in the engineering process. So, a very common problem for engineers that shows up time to time is the issue of being organized. All right. So, when it comes to the design process, it's variable between projects, but it can take weeks, months, or even years to complete certain projects, which is a variable amount of time. Each step of the process can produce documentation, which may need to be referenced at a later stage, right? You may do something, at the beginning of the project, and then have to reference it towards the end. For example, if you did research, right, you're going to want to have that research stored and readily available. If you did an interview with someone, you want to have your notes available. If you have any sketches, you want to have those available. If these documents are not organized, it can be difficult to work in a team or generate a final report. So a good point is at the end, usually you're going to present your findings to someone, or even it could be the sponsor, or it could be your boss at work, and you're going to want to show all the work you've done, even from the very beginning. So if this is something that's taken months to do, you might possibly not remember what you did at the beginning. So it's good to have all types of documentation stored. A common solution to this type of problem is a design notebook. which is used to store documents and notes produced at different stages of the process. It keeps a history of the design project from start to finish. So in a design notebook, you can put notes. You can even do sketches um, of the engineering problem that you're trying to address, um, and anything really that you want that's relevant to the project. Here on the side, we have two takes from engineering notebooks from very famous um, engineers. We have a 1503 page from Leonardo da Vinci, in which you can see him working with water wheels. And then below is a picture of a notebook of Graham Bell. Now, on the following slide, another common issue, perhaps in an engineering team, is communication. The design process is often completed by the collective effort of a group, in which case clear communication is necessary. Groups should agree on roles and proper avenues of communication. If meetings occur, meeting minutes should summarize what was discussed. Um, so you will always need communication at some point. Even if you're working alone, you have to communicate with um, either your project stakeholders or sponsors, um, or a boss. So it's important to keep in mind what mode of communication is best to use, what level of formality is needed. This is more relevant in the case of group work, right, in which there should be a clear sort of tool for communication, be that Teams, or email, or some other type of software, but everyone should, agree on how it is that they're going to communicate with each other. You might want to assign roles. One person might be in charge of, let's say, collecting materials, and another person might be in charge of gathering information. Things of that sort. You don't want everyone trying to complete different parts of a project and not know what other people are doing, because you'll have overlap, you'll have inefficiency. You might actually have something that you think someone else is doing, and then it doesn't get done. These are all things to consider.
Hello, everyone. My name is Lima, and today I want to talk to you about something we often take for granted in engineering and design, the design process itself, and some big challenges it's facing now and in the future. First off, the world of design is getting more complicated every year. We have to juggle a lot of complex requirements, keep up with new technologies that seem to change overnight, and at the same time make sure our designs are sustainable and meet environmental standards. It's a lot to balance. One of the biggest hurdles right now is actually incomplete data. As technology advances, companies can technically gather more data than ever before, but in reality, they often don't get all the information they need. This sometimes means teams are making decisions based on only part of the picture, which can lead to confusing or conflicting feedback. Imagine trying to put a puzzle together without all the pieces. Another challenge is integrating AI into the design process. AI tools can really help us work faster, smarter, but they're also evolving so quickly that it's tough for teams and individuals to keep up. People have to learn new systems, figure out the best use for these AI tools, and actually make sure the AI is helping the project and not making things more complicated. This adds another layer of work for everyone involved, making the process harder, longer, and challenging for everyone. But even with all these new tools and changing technologies, the success of the design process still depends on people. Teams need to be committed to continuous learning and stronger teamwork, not just within their own group, but across all different areas involved in a project. Good communication and coordination with stakeholders is super, super important. Without it, even the best technology advancements can't make a project succeed. So, as we look to the future, it's clear that while technology and AI will keep advancing, the human element, our ability to adapt, learn, work together, will stay at the heart of a successful design. A problem that I come up with is during the design process, what do you think is the most important stage and why? The design process has many stages, as each one is all important on its own. Thank you for listening.